Okay, imagine waking up on Mars. You look outside and see a red, dusty landscape. No trees, no birds, no oceans, and no air you can breathe. Before you even open the door, you need to put on a spacesuit, check your oxygen, and make sure the pressure is safe. Only then can you step outside. And if a tiny leak appears in the wall of your habitat, it is not a small problem anymore. On Mars, a tiny problem can become an emergency very quickly. From far away, Mars looks like the perfect place for an adventure, with giant volcanoes, enormous canyons, frozen polar caps, and landscapes that look like science fiction. So why don't we just move there? The simple answer is that Mars might be a place we can visit, but Earth is the place that keeps us alive. We usually do not notice how much Earth does for us. We wake up, breathe, drink water, eat breakfast, and walk outside without needing a machine for every step. Mars does not give us any of that for free. Let's start with breathing. Mars does have an atmosphere, but it is extremely thin and made mostly of carbon dioxide. Humans cannot breathe it, and the pressure is far too low for an unprotected person to survive. So a Mars home would have to stay sealed all the time. Not most of the time, all the time. The walls would need to hold in air, keep out the cold, and protect everyone inside. Going outside would not be like opening your front door. It would be more like leaving a submarine, except the ocean would be replaced by a freezing, empty planet. And Mars is cold in a way that is difficult to imagine. Some afternoons can reach around 20 degrees Celsius under the right conditions. That sounds comfortable, but temperatures can also fall to about minus 153 degrees Celsius. Mars has such a thin atmosphere that it cannot hold heat very well. Warmth disappears quickly when the sun goes down. Huge dust storms can also block sunlight, cover equipment, and reduce solar power. Now let's talk about water, because without water, there is no settlement. Mars was not always dry. Long ago, rivers and lakes may have existed there. We can still see ancient river valleys, deltas, lake beds, and rocks formed in liquid water. But today, you cannot walk to a Martian river and fill a bottle. Most known water is frozen, including ice beneath the ground and near the poles. Since the atmosphere is so thin, liquid water would not remain on the surface for very long. People on Mars would have to find the ice, dig it out, melt it, clean it, and reuse it. The same water might be needed for drinking, washing, growing food, making oxygen, and producing fuel. On Earth, water moves through a natural cycle. On Mars, humans would have to rebuild that cycle with machines. Food would be difficult too. At first, astronauts could bring meals from Earth, but people staying for years would need greenhouses, artificial light, nutrients, and a constant supply of water. Martian soil would also need to be studied and treated before it could safely grow crops. If the power or air pressure failed, the plants could die. Then there is power. A Mars habitat would need electricity for heat, air, water, farms, communications, and emergencies. Solar output could fall during dust storms, while nuclear power would bring its own safety challenges. Mars is also very far away from Earth. The planets move around the sun, so a spacecraft has to leave at the right time and follow a carefully planned path. With current mission plans, the trip can take roughly 6 to 9 months. That is most of a year inside a spacecraft. During the journey, astronauts would float in weightlessness. Muscles become weaker, bones lose density, and the heart and blood vessels have to adjust. Exercise helps, but it does not remove the problem. Then the crew would arrive on Mars, where gravity is only about 38% as strong as Earth's. We still do not know what living in that gravity for many years would do to the human body, especially to children growing up there. There is no instant help if something breaks. Messages between Earth and Mars can take several minutes to travel in one direction. Mission Control cannot have a normal, real-time conversation with the crew. If a machine fails, nobody from Earth can arrive that afternoon to repair it. The astronauts would need spare parts, medical knowledge, technical skills, and the ability to solve problems on their own. Then we have radiation. Here on Earth, the atmosphere and magnetic field help protect us from dangerous particles coming from the sun and deep space. Mars has much less natural protection. Its atmosphere is thin, and it does not have a global magnetic field like Earth's. Over a long mission, that extra radiation could damage cells and increase the risk of serious health problems. The answer would be strong shelters covered with Martian soil, or perhaps underground lava tubes. But every machine must be launched from Earth, transported across space, and still work when it arrives. Even building a roof becomes a major engineering project. Landing itself is difficult. Mars has enough atmosphere to heat a spacecraft during entry, but not enough to slow a heavy vehicle easily with parachutes. A crewed lander carrying people, habitats, fuel, food, equipment, and a return system would be far more complicated than most robotic landers. There would be no airport nearby, no repair crew, and no hospital around the corner. The landing would need to work the first time, and the challenge would not only be physical, it would also be psychological. Imagine living with the same small group of people for years inside a limited space, with Earth millions of kilometers away. There would be little privacy, strict routines, and no easy way to get away from an argument. So, does this mean humans can never live on Mars? No, it means the first Martian homes would not look like normal homes here on Earth. They would be sealed research stations, more like submarines, polar bases, or spacecraft that never leave the ground. Machines would constantly check the air, water, temperature, power, and radiation. People would recycle water, grow food in controlled rooms, repair equipment, and carefully plan almost every part of daily life. That is why Mars exploration would probably happen step by step. Robots could search for ice, test landing sites, and prepare equipment. Small crews could arrive for limited missions. Later, larger habitats could be added. Only after years of testing would we know whether a settlement could truly last. So why don't we live on Mars instead of Earth? Because Earth is doing something Mars cannot do for us. It makes life feel easy. Here, the air is already at the right pressure. Water is available in oceans, lakes, rivers, and rain. Plants produce oxygen. Soil grows food. The atmosphere helps keep the planet warm, and Earth's natural protection reduces the danger from space radiation. We do not need a machine for every breath. We do not have to count every drop of water. We do not need a spacesuit to walk to the kitchen. Mars is exciting because it challenges us. One day, people may live there to conduct science, build industries, or create a new branch of human civilization. But Mars will not be an easier version of Earth. It will be a place where almost everything has to be built, monitored, repaired, and protected. And maybe that is the most important lesson Mars can teach us. When we dream about escaping to another planet, we sometimes forget how special our current planet is. Every breath, every glass of water, every field of food, and every safe night under the atmosphere is part of a system that took billions of years to develop. Mars may be where we learn how to survive beyond Earth, but Earth is still where we know how to live. If you enjoyed this story, make sure to like, comment, and subscribe to support the channel. See you in the next video.